Okay, for the last section in this chapter, we're going to look at square roots again. We've already looked at square roots a little bit. We looked at perfect squares back in chapter 1. Now we're going to look at kind of additional versions of square roots, we'll say. We're going to look at some irrational square roots in this case. So these are going to be those decimals that never terminate, never repeat. And then we're going to tie that into something called the Pythagorean theorem. Okay, so topic 1, we're just going to go back and revisit the idea of square roots. So we have a few definitions. So first of all, you need to know what squaring a number is. So if we square a number, we are taking the number and multiplying it by itself. That's basically raising a number to the power of 2. Okay, so you just take a number, multiply it by itself. Okay, now the square root of a number is one of two identical factors of that number. Okay, we use this symbol called a radical symbol to indicate a square root. So let's think about that. So we know that if we take a number, let's say 5, and square it, that's equal to just 5 times 5. So we have two identical factors, and they have a product of 25. Well, squaring a number and taking a square root are like inverse operations. They undo each other. So if I wanted to then take the square root of 25, I want to find those identical factors of 25. So the two numbers that are identical that when I multiply them and I get 25 would be 5 and 5. Well, when I find the square root, I just want to list one of those factors. I just want to say, hey, the identical factor pair would just be 5s. So the square root of 25 is just 5, okay? So 5 squared is 5 times 5, which is 25. So the square root of 25 is just 5, okay? Now, a perfect square is a number that has a nice, pretty whole number square root, okay? So we looked at the multiplication table at one point. So if you have a multiplication table like this, let me shrink it a little bit so you can see the whole thing. Okay, so this is your multiplication table. If you look at the diagonal of this, okay, we have the perfect squares. So these values that go down the diagonal of a multiplication table, those are your perfect squares, okay? So I'm going to go ahead and just mark them all real quick. So we've got a 30 by 30 table, and we've listed all of the perfect squares. They go right down the diagonal. So let's think about it. Let's consider 144. So if I look at this 144 on the diagonal, if I go up, I can see that I'm in the 12th column, and if I go left, I can see I'm in the 12th row. So that tells me 12 times 12 is 144. Therefore, the square root of 144 is either the row or the column. They're the same. So we would say the square root is 12 because I'm in the 12th row, 12th column. Okay? So you can use your multiplication table to get some of these perfect squares. Okay? So make sure you understand what square roots are, what perfect squares are. Let's practice. So example 1, it says translate each statement to math and then evaluate. Well, for the first statement, we have what is 7 squared? Well, 7 squared is 7 to the second power, which is really just 7 times 7, or we know and love it as 49. Okay? Well, part B then says what is the square root of 49? Well, we use this radical symbol that tells us we're looking for a square root, and that really translates to what is one of those two identical factors of 49? Well, we know the identical factors of 49 are 7 and 7, so we would say the square root of 49 is just 7. Okay, so that is how squaring and finding a square root work. They undo each other, they're inverse operations. Okay? Now let's look at evaluating some square roots, okay? So example 2 says evaluate, and then it says round to the nearest hundredth if necessary, okay? I'll tell you this, you do kind of want to become familiar with, like, say, the first 15 or 20 perfect squares, because you're going to see those a lot, and if you memorize them and just know them, it's going to save you some heartache and some time. So I happen to know that 400 is a perfect square, okay? So if I wanted to, I could go to my multiplication table, and I could go down the diagonal and I could look for 400. I see it right here. Okay. If I go up, I'm in the 20th column. If I go left, I'm in the 20th row. So that tells me the square root of 400 is 20. Okay. So the square root of 400 is 20. And you don't have to put this, but this is because 20 times 20 is 400. Okay. Now, it is not uncommon to see a fraction with a radical symbol, a square root symbol around it. And so one really cool thing about fractions is if you have the square root of a fraction, you can break this into two separate pieces. Okay, so we could say this is the square root of 4 over the square root of 9. And that's going to help us simplify because we can take the square root of 4 and we can take the square root of 9. So looking at the square root of 4, what is one of two identical factors of 4? Well, we would say that's just 2. And then what is the square root of 9? We're looking for one of two identical factors of 9, 3 and 3. So we would say the square root of 9 is 3. So 4/9 reduces to 2/3. Now, 0 is kind of a tricky one. If you ever get the square root of 0, just know that it is 0. Okay? Now, let's look at the square root of 23. So if I go to my multiplication table and I start looking down the diagonal, I have 1, 4, 9, 16, and then I go from 16 to 25 and then 36, and they just get bigger and bigger and bigger. So I would ask myself, well, where is the square root of 23? And the question is, it's not a perfect square. Okay? So this is not a perfect square. In fact, this is one of those irrational numbers. So we've talked about irrational numbers a couple of times in this chapter. Irrational numbers are numbers that cannot be written as fractions. They are decimals that never terminate, they never repeat. So the square root of 23 is one of those where we're going to have to use a calculator and then we're going to estimate by rounding. Okay? So we want to go to the calculator. And every calculator is going to be different. So when you get to class, if you're using a calculator to find a square root like the square root of 23, you may need to ask your instructor, how do I use my particular calculator? If you have one of the graphing calculators that looks like what I have, we're trying to get to this symbol right here. So the way these calculators work is you have like the main function of each button, and then you have this like hidden, we call it the second function of each of these buttons. And so if I look at this button right here, so going to the very first button at the bottom, the on button, I go up 1, 2, 3, 4 buttons. I see x squared. And in the corner, I see a little blue radical symbol. I need to get to that. So to get to that, I hit the blue second button, and then I hit the x squared button, and that takes me to that hidden second feature of the x squared button. So this is going to allow me to type in a square root. I want to type in 23 and then just hit enter. And that is the square root of 23. This has already been rounded. The square root of 23 is irrational. It goes forever. The decimal never terminates. It never ends. So this is already a rounded version. But even with this, we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 9 decimal places. We don't want 9 decimal places. Okay. Let's actually see what the worksheet says. So the worksheet told us to, well, estimate using a calculator, and then the directions up here say round to the nearest tenth if necessary. So we want to have 1 decimal place in our answer. So let's go back to the calculator. All right. So we get 4.7958, blah, blah, blah. We want 1 decimal place. So the place we're going to round to that's in the tenths place is this 7. To the right of that, I have a 9, which tells me to round up. So I'm going to say this is approximately 4.8. Okay. So approximately 4.8. Okay. So when you have those non-perfect squares, you're going to have to use a calculator to estimate them. Okay.